Here are the answers for the section 9-2 homework. Number 1, we're asked to simplify the expression. It's a multiplication expression, and these two factors have the same base of 5. So to multiply those, we can use the rule about adding the exponents. Write the base, 5, and then add together the two exponents, the square root of 3 plus negative square root of 3. That makes an exponent of 0. 5 to the 0 power makes 1, so this final answer is 2. For question 3, we have a power in the parentheses being raised to another power. So use the rule about writing the base and multiplying the exponents. When multiplying these square roots together, recognize that the square root of 4 just makes a 2, so we get 2 square root of 2. Number 5, before we multiply together, let's rewrite so they have the same base. Instead of 10 and 100, let's rewrite the 100 using a base of 10. So this is 10 to the square root of 3 plus 1 times 10 squared to the negative square root of 3 halves. Then use the rule about multiplying these powers together. This makes 10 to the square root of 3 plus 1 times 10 to the negative 2 square root of 3 halves. Now that we have our expression written with the same base, we can use the rule about adding exponents. Write the base of 10 and add together the two exponents, the square root of 3 plus 1 plus negative 2 square root of 3 over 2. What's left to do in this expression is to simplify that exponent as much as possible. Let's separately do a little work on the exponent over in this blank spot. So we have the square root of 3 plus 1, and then minus 2 square root of 3 over the square root of 2. So the square root of that fraction I have separated into a numerator and denominator. The reason for that is to rationalize. Times top and bottom by the square root of 2. So this makes the square root of 3 plus 1 minus the square root of 6. What's happened is in the denominator, the square root of 2 times the square root of 2 has made a 2, which will then cancel with this 2. This is as far as you can simplify those expressions. So it looks like our final answer is 10 to the square root of 3 plus 1 minus the square root of 6. For question number 9, we're asked to solve an equation. Both the left side and right side have the same base. Therefore, the exponents must be equal. That allows us to write this very simple looking equation. Now let's solve it for x. Subtract 1 from both sides, then divide by 2 on both sides. There's the answer for x. For number 11, we have another equation, and the base is 7 on both sides. So for those to be equal, then the exponents must be equal. This creates a quadratic equation. Let's make standard form by getting a 0 on one of the sides. We could subtract the m away. That'll make a 0 on the left side. 2m squared minus m minus 1. Now we can solve this using factoring, completing the square, quadratic formula, or graphing. I'm going to solve it using factoring. 2 sets of parentheses equal to 0. We just need to figure out what goes inside here. Let's use a positive 1 in this spot and a negative 1 in this spot. The reason is that the outer product is negative 2m, and the inner product is positive 1m, and those combine together to negative m. That's what the middle term is. So from the first set of parentheses, we get negative 1/2, and in the other parentheses, we get positive 1. Number 13. This time we have an equation, but the bases are not the same. So let's rewrite using a common base. I think we can use 2 as the base. So the number 4 is the same thing as 2 squared. And that goes to the 3t power. Over on the right side, how can you write the number 8 but using 2 as the base? That's 2 cubed. And its exponent is t minus 2. Now use the rule about multiplying exponents. So we have 2 to the 6t, and on this side we have 2 to the 3t minus 6. Now we can equate the exponents. The 6t is equal to the 3t minus 6, and solve this straightforward equation. 3t equals negative 6, therefore t equals negative 2. Number 17, we're asked to graph the exponential function with base 3. So the first thing you got to do is make a grid. When I was numbering the grid, I thought about the powers of 3. Like 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, and so on. I didn't want to actually draw up all the way to 27, so I only went to 9. Now let's make an XY table. We need to know where our graph crosses the y-axis, so we have to try x is 0 in our table. 3 to the 0 power makes 1. When x is 1, 3 to the first power is 3. When x is 2, 3 to the second power is 9. You can keep going farther, but you would get 327, and I didn't take the time to draw 27 marks up. We also want to know what happens to the left of the y-axis. So let's use some negative numbers for x. 3 to the negative 1 is 1/3. And when you use negative 2 for x, you would get 1/9. Let's graph these dots. Negative 2, 1/9 is just a tiny bit above the x-axis. Negative 1, 1/3 is a little bit higher above the x-axis, but you're still only 1/3 of the way to the first mark. 0, 1 is here, 1, 3 is here, and 2, 9 is up there. The x-axis is an asymptote, so draw along it and then swing up through the dots. Number 19, we have another exponential function. This time the base is a fraction. I'm expecting decay. So let's make an XY table. And make sure we choose x is 0. 1/4 to the 0 power makes 1. 1/4 to the first power makes 1/4. 1/4 to the second power makes 1/16. Let's do some negatives as well. 1/4 to the negative 1 is a reciprocal, so that's 4. 1/4 to the negative 2 is 16. So negative 2, 16 is up here. Negative 1, 4 here. 0, 1, and then 1, 1/4, and 2, 1/16. And then draw in the curve. Number 21, another exponential function, but this one has this extra +1 on the end. What that's going to cause to happen is that the graph of y equals 2x, which would normally have the x-axis as an asymptote, is going to be shifted up 1 unit. Therefore, the horizontal asymptote will be a line crossing through the 1. We're still expecting this uphill increasing curve. It's just it's going to level out at +1 instead of leveling out along the x-axis. Let's make an XY table. And again, find the y-intercept by using 0 for x. So 2 to the 0 is 1, and 1 plus 1 makes 2. Now let's plug in 1. 2 to the 1 is 2, plus 1 is 3. Now plug in 2. 2 to the second is 4, 4 plus 1 is 5. Now plug in 3. 2 to the third is 8. 8 plus 1 is 9. Let's do some negative numbers as well. 2 to the negative 1 is a half. And a half plus 1 is 1.5. Now let's use negative 2. 2 to the negative 2 is 1/4. And 1/4 plus 1 is 1 and 1/4. That's a lot of dots. I think we can make the graph now. So left 2, up 1, and an extra 4th. and then left 1 and up 1.5, and then 0, 2, 1, 3, 2, 5, and 3, 9. Here's the graph. Number 23, another exponential function. It has an extra times 3 at the beginning, which is going to affect the shape a little bit. And there's an adjustment made in the exponent. Now, this plus 1 is not just added on the end of the entire equation like last time. So this plus 1's not going to move the asymptote line. It's going to have a different effect on the graph. Let's make an XY table. And choose 0 for x. 0 plus 1 makes 1, 2 to the 1 is 2, and 3 times 2 is 6. So the y-intercept this time is 0, 6. Let's choose 1 for x. 1 plus 1 makes 2, 2 to the second is 4, and 3 times 4 is 12. So 1, 12 is a dot on the graph. Let's choose 2. 2 plus 1 is 3, 2 to the 3 makes 8, and 3 times 8 is 24. So 2, 24 is a point on the graph. Let's do some negatives as well. Negative 1 plus 1 makes a 0, 2 to the 0 is 1, and 3 times 1 is 3. So negative 1, 3. Let's use negative 2. Negative 2 plus 1 is negative 1, 2 to the negative 1 makes a half, and 3 times a half is 1.5. So negative 2, 1.5. Do you want to find even one more? We could put in negative 3. Negative 3 plus 1 is negative 2. 2 to the negative 2 is 1/4, and 3 times 1/4 is 3/4. So left 3, up 3/4. We can see that this is going to level out along the x-axis. The effect of the times 3 at the beginning is to make the vertical increase happen much more rapidly than our other examples.